Good afternoon, everybody, and welcome to Public Service University, City of Albuquerque's Lunch and Learn series with Public Service University. Glad to have you all here again. We are going to be with the green team today, and we're going to be talking about ozone and air quality. Just glad to have everybody back. A couple housekeeping things before we get started on today's Lunch and Learn, much like we do every month. We want to make sure that you have your microphones muted. That way we don't hear you talking in the background. What we're going to do is we're also going to take questions at the end of the Lunch and Learn. So if you have some questions, feel free to put them into the chat box, and then I'll keep track of those as we go through the presentation today, and then we'll have our speakers answer those for you. So we do this on a monthly basis where we'll have different topics, and we've been focusing primarily with the green team, talking about different topics every month related to sustainability. We started with solid waste and recycling. Then we worked with the Environmental Health Department, and we are going to be working with the Water Authority next month. And so we'll give you details on that as well as they come. So today, as I said, we are with environmental health again, and we're going to talk about ozone awareness and air quality here in Albuquerque. It's a really interesting topic. And our guests today are Dan Gates and Jeff Stonecipher. So let me just give you a little bit of an introduction to each of our esteemed guests. Dan is a senior environmental health scientist on staff with the Environmental Health Department's Air Quality Program. He has a degree in architecture from the University of New Mexico, and he worked for the city's Albuquerque's wastewater utility division for 6 years, including 2 years as an intern. During this time, he helped establish the pollution prevention program within the division, and Dan has been with the air quality program for 20 years now. Among numerous responsibilities, he operates the pollen counting program, issues the daily air quality index, validates and submits air quality data to the EPA, and evaluates air quality data for attainment purposes here in Albuquerque. So we're glad to have you here, Dan. Also, Jeff Stonecipher is a meteorologist on staff with the Environmental Health Department Air Quality Program. He has a degree in meteorology from the University of Oklahoma, and he's worked for the National Weather Service for 9 years, including 5 as a journey forecaster in the Albuquerque office. Jeff has been with the Air Quality Program for 15 years. He forecasts ozone and particulate levels, issues air quality health alerts, and reviews environmental studies submitted by companies seeking permits. So we're glad to have both Jeff and Dan here today with us. Want to give them our undivided attention as they help us understand ozone and how it impacts Albuquerque, how it impacts our air quality. We talked about smoke and wood burning last time, but I think you all will find this really interesting in what ozone is, where it comes from, and how it impacts our environment. So with that, Dan, why don't you go ahead and turn your camera and your microphone on so that we can see you.
All right, do you hear me?
Yes.
Okay.
All right, we can hear you. That's great. Great to have you back, Dan.
Thank you.
All right, so I'm going to go ahead and share my screen with you, or share your screen, so that you can go ahead and walk us through here and get us started. All right, there you go, buddy.
All right, there we go. Let me click that real quick. All right, do you see that?
I see it.
All right,
Does everybody else see it?
Is everybody good?
I think we're good.
All right, so this is the Lunch and Learn talking about ozone in Albuquerque. And like Tom said, it's just me, Dan Gates, and Jeff Stonecipher. So we'll just jump in and get started. So what we're going to talk about a little bit is, what is the Air Quality Program? And the Air Quality Program, I've been with it for 20 years, but it's an EPA-funded program that monitors air quality. And we have jurisdiction within Bernalillo County. The rest of the state is covered by the state of New Mexico. But here in Bernalillo County, it also excludes tribal and federal lands. Our first monitor in Albuquerque was at the 200 block in Tijeras, just not far from here, and it was started in January 1st, 1957. Since then, we've had 45 different monitoring sites, and currently we monitor criteria pollutants as established by the EPA at 5 sites. And those criteria pollutants include ozone, which is what we're going to talk about, carbon monoxide, PM10, particulate matter 10 microns and smaller, and that's these guys right here. If you look at a human hair, you get an idea of how small PM10 is. And then we also do PM 2.5, which is particulate matter 2.5 microns and smaller. And if you look at this example here of a PM10, piece of PM10, which could be dust, we do see pollen down to about that size. You can put a lot of PM 2.5 particles across even a PM10. We also do oxides of nitrogen and sulfur dioxide. On that list that's not here is lead. The EPA has given us the okay not to have to monitor for lead anymore. In addition to that, we also monitor for several other pollutants that are not part of the required pollutant, the criteria pollutant list. So where do we monitor the air throughout Bernalillo County? These three sites, the blue ones, are where we have our ozone data from. And so we have Double Eagle Elementary School, which is up here in the far northeast heights. Del Norte High School, which is smack dab in the middle of the city center, and it's close to some of our busiest intersections. And then we also have one ozone monitoring station down here in the South Valley. We also have monitoring at North Valley, which is 2nd and Alameda area. And then over here at Jefferson and Singer. And what's important about this is we do primarily PM particulate matter monitoring here. It's because we have the Vulcan open pit facility here. And that's where they do a lot of mineral mining. So if we're going to talk about ozone, a lot of people have spoken to us and said, well, I always thought ozone was a good thing because we have the ozone layer. And well, it is true. Ozone is a good thing if it's up high. The EPA has a phrase that says good up high, bad nearby. So this refers to, if it's good up high, it refers to this ozone layer 10 to 20 miles above us. And that's a good place for it. And this comprises about 90% of all atmospheric ozone. What's not good is when it's nearby. And so when it's nearby us down here at the ground level, or up here in the mountains where we live, it cannot be a good, it can end up being a bad thing. And there's thousands of pages of data that discuss and talk about the hazardous impacts on human health and on vegetation. So what is ozone in particular? Well, it's created through chemical reaction with sunlight, and what happens with the weather. And two of those main precursors, elements that can be converted into ozone, are nitrogen oxides and volatile organic compounds. And in Bernalillo County, those raw ingredients, that nitrogen oxides and volatile organic compounds, are predominantly produced by, if we're talking about nitrogen oxides, cars and trucks. Mobile sources right here are about 63.5% of the source of ozone occurring NOx. Other fuel combustion, such as heating your water, heating your home, those types of things are about 27.3% of that total source of NOx emissions. Now, volatile organic compounds, or VOCs, well, naturally occurring in vegetation and soils about 54%. Cars and trucks after that at about 25.4%, and solvent usage in manufacturing comes in at about 11.3%. So you can see there's a lot of human activity that creates and generates nitrogen oxides and volatile organic compounds. And this is a cyclical process where it comes around, it gets put into the atmosphere, reacts with sunlight, and the weather impacts that as well. And it tends to impact our human health and our vegetation. So the EPA back in 1971 adopted the very first federal standard for ozone, and this is the cover of it, and it reads very differently than federal standards do today. And since 1971, that standard has been revised 5 times. And one of the primary reasons they look at revisions is they want to see if there's new studies and there's new information out there on how it affects human health. And one of the new things they've been looking at over the last several years or decade or so has been how it damages vegetation. And they're actually looking at these two as 2 different impacts from ozone and ozone exposure. And you can see down here a plant that has been exposed to clean air, and then they add in ozone, and you can see that there's quite a bit of damage to that vegetation due to the ozone impact. So I apologize, this is a very busy graph, but really the three takeaways that you need to look at from here is that since 1997, our ozone has improved. So you can see here that we've been in the 73, 76, 77, and then right down in here. And since 2014, we've actually seen a marked improvement. And actually, before 2008, there was only one time during that whole period where ozone was about as low as it's been today. So, but as the EPA strengthens the federal standard here in 1997, the first 8-hour standard of 0.080 parts per million was introduced, and then we met all of those standards. In 2008, they strengthened it again to 0.075, and we got close here, but we were still below the standard. And then in 2015, you can see here, the 8-hour standard of 0.070 parts per million. You can see right here, we are at 100% of the standard. And so we're somewhat of at a watershed moment where this year, 2019, could put us above that number, which would put us into non-attainment for ozone. And what is a little concerning is that if you look at this 37-year average, if you took all this data and average it, our average here is at 0.072. So we could very well be in this range for quite a while, depending on what happens with ozone formation and the weather. And with that, I'm going to hand that over to Jeff Stonecipher, who's going to talk a little bit more about what contributes to ozone and how it affects us.
Well, thank you, Dan. As Dan was telling us, ozone forms when nitrogen dioxide reacts with chemicals like the benzene in gasoline. Those reactions occur in the air, and they are driven by the ultraviolet radiation in sunlight. To get high ozone levels, we need sunny skies, light winds, and plenty of precursor pollutants such as nitrogen dioxide and benzene. You may have heard ozone called smog, and you may be thinking, well, we don't have a smog problem like LA, so what's the big deal? Smog is smoke that looks like fog, and smoke has a lot of ozone precursors and can certainly boost ozone levels. However, ozone itself is invisible, and some of the precursors are invisible. In other words, we can get high ozone levels without smoke. And Albuquerque has had several of those days the past couple of summers. The highest ozone readings in Albuquerque are usually in the Northeast Heights. So if you live in another part of Albuquerque, you may be wondering why you should care. Well, summertime afternoon winds are typically out of the west or the south in Albuquerque. And those wind directions tend to concentrate ozone in the Northeast Heights. And we saw a dramatic example of that last summer. You may remember the compost fire last August. When the wind came out of the south, the smoke moved northward over Albuquerque. Ozone levels increased noticeably at the Del Norte monitor. And so you're probably still thinking, why should I care? Why not let those people in the Northeast Heights have it, right? If the Northeast Heights crosses the threshold that the EPA has laid out, not only will all of Albuquerque be labeled as a polluted city, but new regulations, fees, and taxes on vehicles and businesses will affect everyone, possibly even in surrounding counties. Ozone is a lung irritant that causes serious problems for people with asthma, COPD, and other chronic respiratory issues. That's why the EPA is concerned about it and has set standards. In other words, thresholds that we're not supposed to exceed. The Environmental Health Department's Air Quality Program forecasts ozone levels daily from May through September. airnow.gov presents information on current conditions and forecasted pollutant levels. The Environmental Health Department also issues air quality health alerts through email and to the media, and in addition to posting to social media. The alerts warn people, especially sensitive individuals, of high pollutant levels. And for natural events like wildfire smoke, timely health alerts may also help keep Albuquerque in good standing with the EPA. Cars have gotten cleaner. The newer models produce less pollution than cars did 30 years ago. However, our population, and thus the number of cars, has increased. As Dan pointed out, Albuquerque is close to going over the threshold that the EPA has set for ozone levels. In fact, the Environmental Health Department recently had some sophisticated modeling completed to study days of high ozone levels in Albuquerque. One of the key findings of the study was that half of the locally generated ozone was due to emissions from on-road vehicles. The Environmental Health Department is currently conducting a campaign to raise awareness of ozone. Here are some websites where you can follow our campaign.
So, Tom, I think that's it for us.
Let me just get back up here. Thanks for that, Dan. Yeah, that's really interesting. I don't think I remember the first time that I heard about ozone being a problem. Yeah, you know, same question that you guys addressed. You know, I thought ozone was a good thing, and you know, for so long we heard about the hole in the ozone layer and about, you know, protecting ozone, and then the smell of ozone, you know, after rain and that kind of thing. And you know, I don't think that a lot of people understand or know that ozone is another byproduct that we deal with, and like carbon monoxide and other things, that actually does have an impact. And what was the time frame that how long have we been underneath the EPA's threshold?
Well,
I mean, have we ever gone over it?
No, we never. No, we have not.
And is that just because of the sheer number of our population or where we're located, or prevailing winds coming out of the west and blowing it out of here? Or is there any thought to why that might be the case, that we've maintained such clean air?
So back prior to the previous in 2008, when they looked at strengthening the standard, the scientific community was actually saying that, you know, anywhere between 0.060 and 0.070 would be appropriate. And at the time, at the federal level, they decided and chose to do it at 0.075. So if they had put it at 0.070 at that time, we would have been in non-attainment almost immediately because of where we were numbers wise. I'm hopeful that from 2008 to about now is when, as we've seen improvements in the ozone data, that is the norm. It's more of what is going to hold us into the future. But you can see that historically we've gone all the way up to 0.074, and that's a fairly high level for us. So I'm hopeful with the new technology on vehicles and things like that, we might actually see a continued reduction. I've got my fingers crossed.
Good. So another question related to that: do we have to be at a certain percentage over a period of time before we suddenly no longer qualify as having clean air? I mean, does it depend on what time it's measured? Because we know, I mean, I can only assume that there's certain times a year that might go up, but you know, then in the fall and the spring, when the wind blows all the time, you know, that might have an effect on the particulate matter in the air, and then when it's measured? I mean, it's an interesting question about how they determine
The
it.
federal standard is based on our hourly concentrations, and its hourly values averaged over an 8-hour period.
Okay.
And within a single 24-hour period, you have so many 8-hour averages. And you'll take the fourth high across your entire year and compare those. And if your fourth high is above the standard, then you're non-attainment.
Okay. That's good clarification. It's just, I think some people wonder, it's like, okay, well, when do they determine, that falls in there like that? So we got a question here. Is the level of ozone the reason that you tell people with health issues to stay inside, or is it something else?
Well, it can depend on what's in the air. Sometimes we tell people to stay inside, not because of ozone, but because of wildfire smoke or because of a lot of dust in the air. But when the ozone gets high, yeah, well, that's one of the things that we'll recommend.
Okay, good. There's another question here. Says, we've had mandated no burn nights. Will we have don't go outside days in the future for ozone? That's a good question. Interesting question.
When ozone gets high, that is one of the recommended things, in addition to, especially for people who are sensitive to it. Also, the other things are to, in addition to staying indoors, you want to avoid exercise, avoid any strenuous activity. Those are the key things to do.
And on top of that, we have airnow.gov, which does the air quality index. And our data goes to that website, and it's updated every hour. And so if somebody is concerned about that, the recommendation is that they go to airnow.gov and actually review it for our area.
Okay.
And it'll be mapped out. Mm-hmm.
Great. So here's another question. Does ozone impact kids for life, or do they heal if the ozone is better?
That's beyond my knowledge.
Yeah, it's a question for a doctor.
Yeah.
Okay. But clearly, I guess the question as to whether or not ozone actually causes asthma versus actually negatively impacts someone who has asthma. It's interesting. I've been an asthma sufferer my entire life, and obviously it's better here where we have thinner, fresher air sometimes. But I've never really thought or paid much. I pay attention when I hear the pollen alerts or the blowing dust alerts or the smoke alerts. But until we started talking about ozone, I don't think I was paying attention to the ozone alerts. And I know I have an app on my phone that would actually make send something out that said high ozone. And up until I think we had this first discussion about ozone, a couple months ago, I just looked at it and thought, well, big deal. It's ozone. Ozone's a good thing, right? Now you talked a little bit about some of the things that inhaling ozone, the impact it can have on people. Does it feel like smoke, or does it feel different than smoke and dust? Do you all know? I mean, not without being a doctor, but I mean, how might somebody know if what they're sensing might be related to ozone in the atmosphere?
Well, they can, kind of like with pollen, you can watch the levels of ozone, like you watch the levels of pollen, and if you're having a problem, that might,
right,
correlate. Kind of, correlate and make you want to ask your doctor if you have a problem with it.
And during the summer, when we typically see higher concentrations of ozone is when it's very hot, when it's very dry, and there's almost no wind, and it tends to stick around and form at that point. So if you see that during the hottest part of the day, on a very calm, dry, hot day, if it's bothering you, then you might want to start looking at the numbers, looking at the data, and see if that might be something you'd want to discuss with your medical professional.
Great. Another question here: is there a 20-year forecast available?
I so wish, because when they were doing the last review of the standard, I was kind of on pins and needles, because I knew if they set it at 70 would be above that value. And at the time, I actually knew one of the physicians that worked at Loveless facility, who was in charge of actually reviewing the data and the information and making the recommendation. And when they set it at 0.075, she said, well, congratulations, you guys kind of got what you wanted. And I was not really there because, I had 2 young children, and I was concerned about their health as well. How does ozone affect children and the elderly? But at the same time, as a professional, I was looking at it and going, well, yeah, it kind of made it easier for me in that situation. But it's kind of a catch-22 sometimes if you're sitting in this position.
Sure. So I know you guys were sharing kind of the percentage of where ozone comes from in Bernalillo County, and under the the VOCs, or the volatile organic compounds, you were talking about vegetation and soil producing like 54%, making up 54% of that. So a good question is like, from what? What is that? Just coming out of the soil? Is it coming out? I mean, which vegetations are producing those VOCs that people can be aware of?
Well, different vegetation produces various different things. You go up, you hug one of the ponderosa pines, it smells like vanilla, correct?
Right.
It's producing different aldehydes and other volatile organic compounds that could be part of that. So vegetation produces a lot of things that we typically don't think about until you actually realize that, yes, our natural environment produces a number of these things. And like a lot of things, it's not only that the vegetation are doing these things, but our human lifestyle are adding to that.
Well, and I think it's significant that, obviously, you talked about 50% of this production is actually coming from vehicles, right? And so there's going to be certain times of day where the concentration is going to be higher, obviously, when there's more cars on the road and there's not a lot of wind. I mean, and so how does ozone compare with carbon monoxide?
Carbon monoxide, we're right around 20 to 25% of the federal standard. Since they've made major improvements in vehicle emission controls, carbon monoxide has improved greatly since we went into non-attainment back in the early mid-'80s. And they knew that this was going to be coming down the road as they strengthen the standard, and as we continue to improve our automotive fleet. Hopefully that will be a positive for us.
Okay. So here's another one. Is there a way that we as humans can impact or improve the ozone quality other than just not driving our cars?
Driving less is always positive, and it's something that's been part of the mandate. We're not the only metropolitan area that's looking at this as a potential. I mean, there have been parts of California that have been in ozone non-attainment for so long, probably almost as long as I've been around, or they've been monitoring for ozone. So, and their mantra is the same thing: drive less. If you do errands, combine them, try to do the errands all together. It's like for me, I live within a 10-minute walk to the grocery store. I usually drive. So part of my decision is to try to walk more, and it tells me if I'm doing that, which is good. Thank you to the city.
Yeah, right. So, that's right. I got mine too.
There are little things that we can do as individuals, but I think if we can do small things as a community, which lead to maybe larger things that we do as a regional community, those would be positive things.
Great.
I got a list here of a few other things. You can buy fuel efficient, hybrid or electric vehicles. You can share rides to work, use public transportation, avoid excessive idling of your automobile, refuel your car in the evening when it's cooler. You can buy battery powered equipment for your lawn and gardening.
And remember, tomorrow is Bike to Work Day.
Yes, that's right.
There's always a good time to start.
That's exactly right. And the weather is still not too hot right now, which is really good. So we got another question here. Antonio wants to know, what are the most common technological controls for reducing O3?
Is he talking about as a city or through a fleet of vehicles?
I don't know. Let me see if we can provide some clarification on your question there, Antonio. I'm waiting for him to kind of chime in here. Yeah, it's the most common technological controls for reducing. Maybe you could just answer that question from the standpoint of oh, here we go. In general, what are the methods used to reduce O3 emissions? Just in general, not necessarily for the city, but just in general methods.
Well, ozone is rarely emitted by itself. What's emitted is the nitrogen dioxide as part of fuel combustion. And the VOCs can also be emitted, not only from vegetation, but from paints. So using paints that have less VOCs is a good thing. But reducing NOx emissions from engines, that's the way you control ozone, because ozone isn't emitted directly into the atmosphere. Ozone happens when nitrogen dioxide reacts with volatile organic compounds in the atmosphere in the presence of sunlight. That's where the ozone occurs.
That's great clarification, because I think it happens as a reaction, right? And so if you remove one or the other from the process, that's awesome.
And it's kind of funny because that study that Jeff had talked about, one of the discussion points was there is that if we reduce our NOx emissions, could it possibly increase our ozone concentrations? At the same time, if we reduce our VOCs, could it do the same thing? And so part of that is a balancing act. Since it is a reaction in the atmosphere, we don't want to exacerbate the problem by attacking a precursor pollutant and causing a bigger problem for us.
Right. Let's see if we have any other questions here. Dana wants to know if everybody's going to bike to work tomorrow. Are you guys biking? Dan's biking to work.
I do every day.
Yeah, good for you. I live in northern Rio Rancho, so I want to bike to work.
They have these things that are little electric motors in them now, which are awesome.
Yeah, I know. I saw it. Well, and I can take the rail runner as well, which is helpful. Yeah, and actually, for those of you that you're asking that question about biking to work, we have a great bike program where you can actually rent a bike and we have now bikes parked almost all over downtown now, and you can literally bike to lunch and bike from where you're parking or where you're moving and that kind of thing around town. Bike share program, which is really, really great. So
and a really great free bike shop. It's Esperanza.
Is it? Yeah, or is it? Yeah, I think that's what it is. Esperanza. Yeah, and they'll help you out if your bike needs a tune-up or whatever. It's great.
And they loan you the tools that you need. It's a great place.
So I think it was really interesting what you shared about just even our lawnmowers, our weed eaters, and all of our, all those tools, because especially now, they make electric versions of those tools, and I don't think a lot of people really think much about it, about how many, what kind of NOx I'm putting into the atmosphere with my lawnmower running in the back, and I guess a good question. Those 2-cycle engines put out, it's different than what they're putting out than what's coming out of the tailpipe of my car, right?
Well, yeah, because you don't have a catalytic converter on your
right. Yeah, I kind of set you up for that one. Yeah. Exactly. Well, right. So actually, what's coming out of the lawnmower is much worse than if my car is idling when the lawnmower is idling.
Right. But you're burning less fuel, so there's a payoff there.
Yeah. But it's at least something that we can contribute. All right, let's see if we have another question here. Does the depletion of the ozone promote climate change? Is it the biggest driver? That's what Dana was asking. Does the depletion of the ozone layer promote climate change?
Oh yeah, that's way in the stratosphere.
So if they're asking about the ozone layer, then that's not what our focus is on at this point. Here locally, if you're reducing ozone, you're improving human health and vegetative health. So we see it as a
So,
positive.
so I guess, just a non-technical question, I think related to this, because we use the same word, ozone, for
Mhm.
what's in the atmosphere and then what's down here on the ground being produced as a chemical reaction. Producing this ozone down here doesn't float up to the sky and replenish our ozone layer, or
Because
does it?
it's a chemical reaction.
Right.
So the ozone, as it travels to different locations, is going to break apart, recombine, become other compounds. So
Right.
it's not a static compound, ozone itself.
Right. So yeah. So, and I think a lot of people probably might get confused about this, because when we use the word ozone, that's an automatic assumption that we're talking about what we've been talking about for years with our ozone layer.
Right.
But
And so
we're,
so part of the educational process is to try to use the term ground level ozone,
that's
because
good.
that's very specific to where we
Yeah.
live at the
Yeah,
ground level.
that's great. So the answer to Dana's question is no, we're not depleting the ozone layer when we're eliminating ground level ozone.
And I mean, you're talking about CFCs and other molecules that would actually go up there and break apart ozone in the upper atmosphere, and that's slightly different than somewhat of the compounds that we're talking about today.
And those CFCs and things don't break down the ground level ozone like they do by the time they reach the atmosphere, right?
Couldn't tell you, because I haven't looked at that myself.
Yeah, I think, it's interesting. I think what happens, educating anybody on a situation, or trying to really understand, especially when we've had language and we've been exposed to certain things over time. Like even the smell of rain, to say, well, what you're smelling, you're smelling ozone after the rainstorm, but what we smell is not the same ozone what we're talking about that we're creating out of the tailpipe, or is it?
It's still a chemical reaction. It's still
It is.
molecules of oxygen. Yeah.
Right.
Ozone. There's no real difference between
Okay.
ozone A and ozone B. Yeah.
But so, right, because someone might think, well, if I breathe after it rains and I smell that, then I'm going to damage my lungs. You see that where their confusion could be, and understanding it's like we're creating this chemical reaction with what we're putting in the atmosphere, and when it hangs around at the ground level, these are the effects that it has on people. And so we just really helping people understand what is in our air. And I think that's the big thing that a lot of people don't know, is like what's really in the air that I breathe every day and I take for granted. And am I making it better or making it worse with my behavior, where I go, what I do? Just even advising people to fill up their vehicles when it's cooler outside, which reduces the chances of this chemical reaction taking place, right? That's the idea behind that, because you're removing heat from the equation. And that's something that anybody can do very easily, which will have a really big impact. All right, let's see if we have any other questions. We have a little bit shorter lunch and learn today, which is great for everybody's schedules out there. But if anybody else has any more questions that you would like to ask, we'll go ahead and answer those before we start wrapping this up. I think it looks like that's it. Well, guys, I just want to thank you so much for coming on and continuing to enlighten us about, what we're breathing and what we're doing to our atmosphere. I mean, like I said before, we take it for granted, much like the water we drink. We kind of take it for granted. We just go about breathing every day, and then and don't. We complain about it when we can't breathe, or when we're choking, or when we're getting sick, but to actually stop and think about, well, what is happening? What is causing this? When I go buy a can of paint and it says low VOC, it's important to know what that means and how it's making a difference and contributing, so that it's not just a phrase or a slogan. It's something that really actually matters and makes a difference to what we try to do. So You guys are some of the smartest guys at the city, and it's just great having you on here and sharing your knowledge with everybody. And I really appreciate you taking the time to be here. Is there a way that anybody can contact you? What's the best way to contact you guys over environmental health?
Our emails,
You want to share those?
yeah, J Stonecipher at cabq.gov.
And dgates@cabq.gov.
Great. Yeah.
For me, all I have to do is look on the pollen page and I'm there. So
Yes, on the pollen page. That's great. Yep. Awesome. Thanks, guys, so much for being here. I really, really appreciate it. And we just want to let everybody know that we are going to have another Lunch and Learn next month. Usually the green team will go 2 months and then take a month off from green team conversation, but we're actually going to have a Lunch and Learn next month with the Water Authority. We were just talking about water, so we're going to talk with Water Authority about our water system and about how our environmental sustainability is being impacted here in Albuquerque and the great things that they're doing. So that will be on June 20th at noon, tentatively. And of course, just keep your eyes on eWeb and in your email, and we'll let you know. Also, coming in July, we're going to have another Lunch and Learn that we're scheduling on mindfulness and what it means to be mindful as we continue to go through this series and educate you right at your desk. So we just want to thank you so much for being here. Thanks to the green team for being willing to come on here and share this information. Just want to remind everybody about Bike to Work Day. It's exciting. So if you've got a bike, get on it and ride it tomorrow. And if you don't,
they give away free things at the station. So there you go.
There you go. Yeah, that's awesome. So Bike to Work. Thank you, everybody, for participating in Earth Day last month. It was a success. We had lots of awareness, lots of involvement. It was really great. And just stay tuned here. We will see you again, and we thank you so much for your participation. So enjoy the rest of your day, and we will see you all at the next Lunch and Learn. Bye-bye.